Hello, everybody, and welcome to today's SIT Alumni Insights, where we're going to learn more about the innovative education model at the Schaffhausen Institute of Technology. My name's Mark Barton, and like you, I'm very curious to learn more about this brand new master's course in computer science and software engineering. I'm very excited today to hear from today's world-class speakers, but also, and this is what makes today very special, to hear from the SIT alumni themselves who will be sharing their experiences on learning with industry leaders and top scientists. What I'm fascinated to hear is how this course will empower you with the industry's most desired skills to compete for C-level positions in the world's top-level organizations or to run one of your own. Here's why we're lucky today. These are the four gentlemen we're going to hear from today. Four world-class speakers, and what makes it special is all four are associated with SIT and this brand new MSc in computer science and software engineering. Dr. Sergey Belousov, the founder of SIT, the CEO of Acronis, Professor Konstantin Novoselov, the Nobel Prize winner, the chairman of the Strategic Advisory Board at SIT, Dr. Stanislav Protesov, president and co-founder of SIT, an honored guest lecturer at SIT, and Professor Bertrand Meyer, who is SIT provost. Not only will we be hearing from these world-class speakers, what makes today special, as I said, we're going to hear from SIT students themselves to share their experiences about working with top industry leaders and the world's best scientists. Arpita Ghosh, product management student at SIT. Vasily Zorin, information systems student at SIT. Emmanuel Gael-Gedia, computer science student at SIT. You're being spoiled today. And Daria Kublikova, information systems student at SIT as well. Very quickly, just want to run through today's agenda. We've got a packed agenda today, kicking off with Dr. Sergey Belousov, the future of computing. Then we'll hear from Professor Novoselov on intelligence and computing with materials. We'll have a short Q&A session afterwards. Then we'll have our first case study on research with Bertrand Meyer and Emmanuel Gael-Gedia. Then we'll have our second case study on business from Dr. Stanislav Protesov and Arpita Ghosh. And at the end, we've got a very special Q&A. That's when you get an opportunity to ask all our speakers questions about this innovative education model at SIT, and more importantly, this brand new MSc in computer science and software engineering. This is where I tell you about the function at the bottom of your screen. Do you see that Q&A function? Please press that button and send your questions through. Our SIT colleagues are sitting here waiting to answer your questions. And as I said, we've got world-class speakers and SIT students who will be answering your questions at the end as well. Please use this Q&A function. It's a wonderful function. We're desperate to hear from you. You, of course, who I'm sure are eager to learn more, to listen. You who are fascinated about this brand new MSc in computer science and software engineering. Please, if you're interested in this course, go to the bottom, sit.org/admissions. That's where we want you to apply, or you can just go to the website, sit.org, sit.org, or sit.org/admissions. Please go there. We're very eager for you to apply. And of course, if you've missed today's speeches, or if you want to watch them again, everything will be available on the SIT website. Like I said, sit.org. Without further ado, it gives me enormous pleasure to introduce Sergey Belousov, who, as I said, he's the founder of SIT. He's one of the brains, the inspiration behind this MSc in computer science and software engineering. Today, he's going to be speaking on the future of computing. Sergey, I'm going to hand the floor over to you.
Hello, everybody. This speech, which I'm going to show, I can show in 15 minutes and 30 minutes. but it's really a 1 hour speech. So bear with me if it's going to be a little fast. So first of all, I want to talk about the problem which Acronis is solving. And the problem is that computing is eating the world now, solving a lot of world problems. And computing is very, very fragile. And protecting it is complex, it's expensive. It's very important at all times to remember about security. Security is now, cybercrime is now industrialized. It's super important to remember about privacy. And not only computing is effectively essential need for everyone. And for that, Acronis came up with cyber protection. There are similarities between biological hazards and computer hazards, digital hazards. And in both cases, you need to do all these things together: prevention, detection, response, recovery, and forensic. Only then you are fully protected. Most of the time, you're best protected if nothing ever happens. And most of the time, in order for nothing ever happen, you need to actually do forensic. So this is actually a circle. For that, Acronis came up with integrated and autonomous cyber protection. And Acronis' mission is to protect all data applications and systems, safety, accessibility, privacy, authenticity, and security. We call it Acronis Cyber Support. In such a way, it is only possible to create a solution which is easy, low cost, secure, leave control in the hands of the customers, and it's reliable. And effectively, Acronis does one thing: autonomous integrated modular cyber protection for customers, offered through cyber cloud, through partners, service providers, based on cyber platform, so it can be extended, integrated, and customized using Acronis cyber infrastructure. So it's local to your business, and it's very, very cost effective and easy, and augmented with Acronis services. With that, Acronis is headquartered in Schaffhausen, in the same place as SIT, and has second headquarters in Singapore. And it's a medium-sized company with expertise specifically in cyber protection, cyber engine, which includes security and artificial intelligence, computer science, software engineering, because it's a large platform. Building platform is the best thing you can do if you're a software engineer, and in specific expertise related to basically usage of artificial intelligence in different human fields. However, this is just one problem we're facing. There are some more general problems which are facing the world: diseases, environment, social justice, wars and violence, space universe challenges. You know, my favorite problem is aging. I really am not looking forward towards my birthday, which is less than 2 weeks from now. And for what we know about the universe is a computer. And computers can be used to predict just about everything in the universe. On the right, we have an example of making drug discovery using computers. Almost all drug discovery are done by computers right now. What is a computer? Digital computers, which we use today, are effectively equivalent to Turing machines. So all this advanced technology, CPUs, GPUs, TPUs with tens of billions of transistors are just 2D or 3D versions of 1D Turing machines. And there is limitations. There's not going to be 4D. With that, there is already an evolution of digital computers, which actually is building specialized computers for specialized needs, such as neuromorphic computers, which are designed for deep learning, machine learning, photonic computers, which are also very good for deep learning, for machine learning, because they're they have very, very high frequency, and they are very good for simple, highly parallel operations. Many of those computers are already shipping. But with digital computers, we will hit hard limits before we solve some really hard problems. The well-known Moore law is no longer working. It's no longer possible to double number of transistors every 24 months. And with digital transistor computers, we will hit performance through output limits, power consumption limits, and the computer size limits. The well-known complexity theorist Scott Aronson estimates that we will hit those limits in 25 years, and there are fundamental limits on the left, which will be hit regardless in relatively short time, 75 years or 60 years, based on our estimates. There are these two simple problems. One of them is many-body problems in physics, effectively predicting how the nature behaves and how the materials behave. And another problem is large integral primer factorization. And you can easily come up with systems which can never be solved on any digital computer which can possibly produce. So there is upcoming revolution. There are new kinds of computing, quantum computing, such as this computer, which was the first computer breaking any possible record of digital computer, which was available last year. This is 3 examples of most popular architectures and groups of guys who are building quantum computers. All these quantum computers are already in some form available today. You can do some calculations on them. There are more futuristic designs like black hole computers or advanced material computers. On the right, again, you can either theorize about black hole computers, or you can actually see some advanced materials computers already today. Advanced materials is a very perspective way to approach computers. Ultimately, most advanced computer is a human body and brain, and that computer can solve some unbelievably complex problems which we do not know today how to solve on the conventional machine, just consuming 10 watts of power and weighing 1.5 kilo. But you know, reality is that we need some advanced computers very, very soon. We need it for robust sensors and actuators. We need it for quantum internet. We need it for advanced material simulations. We desperately need better materials. We need to have better storage. We have a lot of data, and we want to augment human bodies. This is just one example of quantum internet. Reality is that the only way to keep the secret is to use quantum internet, and for that, you need quantum repeaters, which is a small quantum computer. The good thing about these new generation computers, they can be plugged into the world computing architecture very, very easily. You have CPU, GPU, TPU plugged in today. You probably have memory star array and photonics also somewhere in Google, Amazon, and for example, Microsoft Cloud's quantum computers will be plugged in and available real soon, if not yet, and they can plug in all these computers. However, to build these computers, there are a number of interdisciplinary problems to solve. First of all, new computers will require new advanced materials. Then new computers will require new, completely different hardware. New computers will require new, completely different software. New computers will require completely new software to not only design them, but also to run them, and new, completely different application software. And for that, we decided to build SIT, which is Computer Physics and Business, which is a small focused university. I want to basically, this is a slide I'm showing for the first time. This is the idea of SIT. SIT is driving technology and education business to generate unconstrained funding and other value needed to produce world-class science. So the core of SIT is SIT Foundation and SIT University, which are non-profit. But next to SIT and in SIT, there is a for-profit SIT holding, which includes this interesting 9 members SIT Zone, which is producing a variety of different services for technology and science companies and its members, SIT Transformation Consulting, SIT Autonomous, SIT Alimira, and SIT Academy. And these very, very profitable and highly commercial companies produce founding, developing, funding, and servicing tech needed for SIT Foundation to fund SIT University, versus SIT University produces reputation, people, knowledge, IP services needed to fund those companies. And this whole operation is based in SIT Zone, which is both physical and virtual, and both global and local. But of course, the headquarters and the main place for SIT is Schaffhausen today. The focus of SIT University is just these 3 high-level fields: computer, physics, and business sciences. I want to stop for a second on computers and physics. So cybersecurity and information integrity, artificial intelligence and machine learning, software engineering, robotic and autonomous machines. These specific fields in physics, quantum technology and advanced materials. In business is basically applying computers and physics to various human problems. And examples of those problems are here: digital health, new generation business management, digital learning and education, AI in arts and design, and so forth and so on. I want to point out that almost none of the modern problems are solved by any of those disciplines alone. Almost every project, such as, for example, highly desired autonomous cars, are only possible to be built with an interdisciplinary approach. And you need to have at least some people who understand, to some extent, every field of these approaches to actually solve the problems of building autonomous cars. How can we do it? Well, first of all, we do it in a partnership with Carnegie Mellon University and National University of Singapore. Second of all, we do it with a group of advanced individuals who allocate some of their attention and time to help this. And this is the most important part of the university. This is a scientist involved, members of strategic advisory boards. On the physics side, Kostya Novoselov, who is a Nobel Prize winner, he'll speak later today. Misha Lukin, Harvard University professor, expert in quantum technology, building the most advanced quantum computer today. Nicolas Jezan, who built the most advanced quantum communications. People in a computer science field, people in the business science field from leading universities, leading scientists. Also, of course, members of our board, members of our executive management, members of our industry connection, and variety of our friends who are helping the university, contributing hours, and ready to be participating in science and education process. This year, we're launching a Master of Science program. There will be more detailed speech about the program. I just want to stop on several differences. First of all, this program is targeted towards preparing enough knowledge in the leaders. We believe in the modern world, no project can be built without software. And typical software project is not small. It's 1,000 man-years, 100 people, 10 to 100 releases. And so it actually is a project which requires 5 to 8 type of leaders, which are listed on the left side. But really the project which you want to participate in, really successful business or science project, will include thousands of people and 10,000s of man-years, and will require all the leaders on the left side. Some of those leaders are quite familiar probably to you, such as, for example, Chief Technology Officer. Some of them are perhaps interesting. There is a big difference between Chief Architect and Chief Engineer. There is interesting roles like Chief Idea Officer or Chief Science Officer in any software project, and we teach how to play those roles. The second difference is, beside leading the teams of leaders, is a connection, and the connection to advanced people is transformational leadership, science of people, business sciences. We believe it's important to teach computer scientists, business scientists, quantum informatics, which we feel is the future. We feel there are going to be a lot of software to be written for quantum computers. Advanced material science, we believe, again, there's going to be a lot of software written for advanced materials and written based on advanced materials. And another thing which we truly know how to help you to understand is entrepreneurship. This is an alumni event, so in some ways I'm talking to people who came to listen, but I'm also talking to people who came to speak, our future alumni. They haven't graduated yet, but hopefully they will graduate real soon. And I want to stop for a second on what is entrepreneurship. So first of all, what differentiates an entrepreneur, and can you teach entrepreneurship? And you would think about these qualities: smart, high IQ, education, network, luck, hardworking. In reality, this is not really important. Many of entrepreneurs don't have any of those qualities. They don't have a good network and connections. They don't have luck. They're not super hardworking. They're not good people. However, what they have is this 11 qualities: ambition, initiative, empathy, alert, being responsive, detail-oriented, making decisions, never giving up. And as such, you don't need luck if you never give up. Frequency, passion, and care. I cannot have enough time to talk about this. I think this is a good movie. If you want to be an entrepreneur, you need to be prepared to be like this guy in this movie, There Will Be Blood. Also, very often people ask me and tell me what they do, and I want to explain how entrepreneurs actually make decisions of what they want, or what they actually do, how they build their businesses. So basically, you can do what you want, or you can do what you should, but in reality, you can only do what you can. And what you can is based on the, most importantly, opportunity. And opportunity is highly dependent on your ability to execute and your ability to come up the strategy, which is a differentiation, capabilities, and focus for these opportunities. And if you do not have the right opportunity, and you do not have the right execution skills, and you not have enough strategy, instead of trying to pick something which is not ideal for you, you should go back and acquire knowledge. At some point, If you keep acquiring knowledge and execution skills, the right opportunity will come along. But it's important that you should only do what you can. And with that, I want to finish my speech almost on time. What can you do now? First of all, you can become Acronis CyberFit. Unique feature about Acronis, you can be our customer, partner, employee, engineer, and executive. We will double our headcount in the next 3 years. You can join SIT as a researcher or faculty, or you can sponsor and invest or buy SIT services. We are going to produce highly competitive services. For example, SIT Autonomous Platform and Autonomous Machine Consulting, for example, SIT ALUMNI. Also, SIT is actively looking for students for our unique master program, which I'm sure my colleagues will talk about today. You can apply now. Why should you apply? It's very simple. It only makes sense to apply to a program which can make you to be as successful as Alan Turing as a computer scientist, or as successful as John Bardeen as a physicist, or as successful as Larry Page and Sergey Brin in business. Thank you.
Sergey, thanks very much indeed. Fantastic speech to kick off today's proceedings, and happy birthday, by the way, in a couple of weeks' time. Sergey Belousov there, the founder of SIT and of course, Chief Executive Officer of Acronis. And why should you be interested in this new MSc in computer science and software engineering? Well, among the many things Sergey talked about was entrepreneurship. What you get is hands-on experience in building a new high-tech company. And there's very few people out there who know more about building high-tech companies than Sergey Belousov. He's created many, many of them. He knows what it takes. I want to move swiftly on because it gives me enormous pleasure to introduce our next speaker. It's not every day you get to hear from a Nobel Prize winner. Professor Konstantin Novoselov is just that. He's also chairman of the SIT Strategic Advisory Board. And his talk today, as you can see right in front of you, is on intelligence and computing with materials. Konstantin, I'll hand it over to you. Thanks for joining us today.
So thanks so much. It's a great pleasure to talk today, because the program for SAT, the very concept of SAT is being developed and being polished as we speak. And one of the most exciting thing about the master program is that we are switching to a new basic directions for our research and education. So we are moving from the standard selection of disciplines, and we're creating our research vectors along the new directions, such as the quantum information, material science, computer science, and artificial intelligence. But also within those directions, we're trying to create some synergetic projects where we can study the use of quantum computation for telecommunications, or for computations in AI. And one of these directions I would like to present today. So how can we link advanced materials with computing and with intelligence? And generally, of course, materials have been traditionally very important for computing. Let me just give you one example. Here is the list of elements which we used in the production of our silicon chips prior to 1990. And at that time, it was a very, very simple technology based mainly on silicon doped with boron or phosphorus, aluminum for interconnects, hydrogen, oxygen for passivation. Then after 1990, the density of transistors on the computer chip increased, so we needed copper interconnects, and then because of that, new materials for the control of the contact resistance. But if we look at the elements which we use in modern silicon technology, we see that we use half of the periodic tables. And the situation is quite bizarre, because if I ask you which elements do we have in our body, you will actually see that we have many more elements in our silicon technology than in our body. And as Sergey already mentioned, probably the most complex computer ever available to us is our brain. And yet, in terms of technology, it looks like the complexity of our silicon technology goes above the roof. So one of the basic reasons for that is that we really bet on one single material, silicon, and then we amend our technology to fit new realities, to fit new demands. And that's a general approach. As human beings, we really rely only on a few materials like silicon for electronics, steel for construction, aluminum for aerospace. So really, a few materials means narrow opportunities. And that's exactly why we really need to invest a lot into research on the advanced materials, because, for example, by combining different materials together, we can create advanced materials, and those are already being used and really enhance our capabilities dramatically. And ultimately, what you want is really to mix many different materials together to create a specific material for any particular applications. And you would like to do it by at least layer by layer engineering, maybe even by atom engineering zone, and then you can assign specific properties and specific functionalities to every layer, and then create very complex functionally those materials. So one of the possible platforms is which we use is the 2D materials, and graphene is one of them. So we can imagine we have materials which are only 1 atom thick, so they're quite exciting by themselves. But what you can do, you can put them together as pages in a book, and then encode much more complex stories than any one single material has. And this technology is being developed right now. We have already many different devices based on such technology. But as I said, this is only one possible opportunity. So generally, we would need to develop a generic approach, how to create materials with predetermined properties, but probably more important, with the predetermined functionalities as well. And now I would like to really go from materials and properties to functionalities. And this is quite a new concept, because generally, very traditionally, we would always separate materials which have properties and functionalities which usually come when we structure those materials. Like silicon, it has properties and functionalities coming when we create transistors out of this material. But it doesn't need to be this way. We don't need to separate the materials and the functionality. If you look at biological structures, functionalities come on many different levels. Like biological membranes, they have functionality. They come together into a cell, and each of those of the organelles would have its own functionalities. Those cells combine into organs into bodies, and the functionality is distributed from material level to the organ level. So how can we design material with the predetermined functionalities? And can we build materials on the hierarchical principles, so they would be able to solve certain problems by themselves without the use of the CPUs, as Sergey spoke about? Well, one of the possible ways is really to use materials without bulk, because we want them to interact strongly between themselves. And I won't go into details, but there are many different materials without bulk, including 3D, like metal organic frameworks. And we would also like to use the live materials like organelles or bacteria, viruses, and then we can combine those materials together using specific combination rules which are based on the interaction between those materials. And then we can create complex heterostructured materials, and those heterostructured materials that will have functionality, that will have intelligence built inside them, because we can make them in such a way that they would be reactive to external stimuli, but this response would affect the stimuli itself. So they would be able to develop memory, and it already means some sort of intelligence. So I won't go much into details how we can do it. So it's really there is quite an interesting mathematics on the basis of the complexity and intelligence of those materials. But at least having those combinations of the materials interacting through known pathways with many different types of energy involved would allow us to create those intelligent functional materials. So how can we create those materials, and what are the basic ways how to predict materials with the given functionality? And I would like to argue that here is one of the way material science, advanced materials, would interact strongly with the computer science, because currently we don't have in our disposable any means to predict new materials with given properties, let alone functionality. So the only possible way, I think, would be the intensive use of artificial intelligence, and we start to use it already. Drug discovery these days is being done with the help of AI for a number of years already. In a sense, it's not that difficult. So the most difficult part is to describe a material or small molecules for the computer in such a way that certain good properties, or the properties which we are looking for, would be encoded there. So those descriptors, we have ways how to produce those descriptors. It's a little bit more complex when we start talking about materials. So how to explain to an artificial network what is a material, and how components interact inside of the material, and what kind of property do we want to gain out of the material. This is not a very simple task, and that's exactly why we need very close collaboration between the material scientists and between the computer scientists. And that's exactly what we're trying to develop in SAT, to create an environment where these people can work closely together and interact on the day-to-day basis, and try to solve those problems. And that's generally one of the main problem, I think, in modern computer science. So deep neural networks, they've been developed quite intensively now. Material science, we understand the basic principles, how those components interact. But to solve the problem of the inverse problem of creating material with the predetermined functionality, with the predetermined properties, we really need this interface where nobody is working right now, or only a few people really operate here. And that's exactly where the most interesting tasks are sitting, and that's the problem which we are going to tackle in our in SAT. And of course, once you create those materials, you can use them and build your neural networks based on those materials themselves. If you create functional and intelligent material with memory, then you can use it to create a memoristic network, and that's exactly what you need for your deep neural network. And probably most challenging, I don't have a solution here, but we can in principle try to use the same network to solve the properties of the components themselves, and probably it will be a link to the intelligence and to the way to create true artificial intelligence. I think I will stop here, but basically to say that those new adaptive intelligent materials which we are going to create using intensive collaboration with the computer scientists, with the artificial intelligence, will be at the basis of many new smart applications, and will create new artificial intelligence as well. And we're really looking forward to have more bright students in SAT to tackle all those problems. Thank you.
Konstantin, thank you very much indeed. That was absolutely compelling and fascinating. You're going to stay with us. We'll be back with you in just a second. And this is just another reason why you should all choose SIT to do your masters. You've got direct access to world-leading research centers. You have top-class academic instructors for deepening learning experiences, and of course, extended technical disciplines, advanced materials, and quantum technologies, such as Konstantin was just talking about there. Please use the Q&A function at the bottom of your screen if you have any questions regarding today's master's program, or you can go to the website sit.org or sit.org/admissions. If you've got any questions, we're always on standby to answer them, such as how to apply, what documents you need to apply for the course, how to get a visa to be educated in Switzerland. That's a really important question, something we can answer easily in today's Q&A or on the sit.org website, and how to get a full scholarship and have the chance to study for free at SIT. So please bang that Q&A function at the bottom, or go to the SIT website, sit.org, sit/admissions. By the way, if you missed any of today's speeches, wonderful speeches or panels, you can find absolutely everything on the website, sit.org. And please do apply on that website, sit.org and sit/admissions. Right, it's Q&A time. Konstantin, you're staying with us. Sergey is also with us as well. Please keep firing in your questions, and we'll ask questions to both Sergey and to Konstantin as well. Sergey, if I could start with you. We've got one question here from one of our BA students today. Why should I choose SIT as opposed to an established university like ETH in Zurich?
Well, I think the way we think about this is that there are these problems which humans face, and these problems may be humanitarian or may be strategic or maybe business value. Most of the time they're business value. And in order to solve them, there is only one way, is to generate required knowledge through science. And we believe that whomever solves them should be able to fund and resource needed science. And so the way we start SIT is that we started from problems, then we find the resources and the funding, and then we build it with science. We, as such, basically prepare you to solve those problems. As such, first of all, with this master program, I mentioned those differentiators. All of those 8 sins are critical. They are more critical than the name of the university, because ultimately you can work for in a scientific group of somebody like Kostya in any university, and you'll be better off if you will be working in a mediocre group in Harvard or Cambridge. Entrepreneurship is also important. People think about entrepreneurship about making money, but not really. Entrepreneurship exists in science. For example, what Kostya is doing right now with advanced materials and starting this new research center is entrepreneurship in science. It's in a different place. Kostya was very comfortable in Singapore, in Manchester, but now he's in Singapore, starting something completely new. Leading teams of leaders, very, very special thing. You cannot build anything in a small group, and you need to deal with other leaders, and you need to be a leader, and you need to have a specialization. Preparing for change. Everything changes all the time in science. Science is a very fluid field, but it's actually by now the same in business and the same in technology. You need to talk to people. Even in science, most of the time what you need to do is not actually to think, but to figure out who can help you think, what the other people think. Being able to understand things about business. If you're a scientist, if you're a computer scientist, you can only understand it if it's formulated in the language of computer science. And by now, we know how to formulate just about everything in the language of computer science. Quantum informatics, something which is unique when it's taught to software engineers, not computer scientists, but to software engineers. How is it relevant to software engineers, and what can they do with quantum computers or quantum sensors or quantum communication? And of course, advanced materials is an absolutely amazing field. It's probably the most exciting field I have heard of, which has everything to do with everything. Can you find another university which has a master program in computer science and software engineering, which allows you to work through learning, and which allows you to be getting interdisciplinary degree with all these 8 things? I don't think so. You know, of course, you can find other brands of the universities, but it's really not about the university brand. It's about people.
Sergey, stay there. Konstantin, got a question for you from one of our audience members today. Is there any difference between advanced material computers and quantum computers?
Yeah, so there is quite a difference. So of course, the advanced materials, everything is based on advanced materials, and some of the quantum computers are built on the advanced materials as well. So, but for the quantum computations, we use qubits, and we use the quantum different quantum states for the computers which are based on the advanced materials. We don't necessarily use the qubits with the different quantum states. So we can, and those can be actually built based on different principles, say phase changing materials. You can build memristas with them, and you can build neural networks, or you can build a purely analog computer, or you can use another silicon. Well, I don't know what's going to be after silicon, gallium arsenide, or molybdenum sulfide. So there is clearly a difference, but many of the quantum computers are based on advanced materials. Some are not. So there is a difference, but those two fields do overlap as well.
Thanks, Konstantin. Sergey, I've got a question for you. I really liked your slide, which highlighted entrepreneurship. You had one column, and I'm sure all the audience were thinking, oh yeah, I've got all those things. And then you crossed it all out and said, that's not what it takes. And then you had your second column, which listed all the attributes you need. Do you think there's a general misunderstanding of what it takes to be an entrepreneur?
Yeah, there is a general misunderstanding because most of successful entrepreneurs are not serial. And so their success is based on those qualities, but they are not really understanding why. And most of the serial entrepreneurs are so successful that they don't really care to share or analyze why they're successful, because it's very tiring to do this work. It's very stressful. But at the same time, this is, when I would show these qualities to any entrepreneur, successful entrepreneurs, say 100 million, a billion, several billion-dollar person who made this money through multiple times, they would agree because it's pretty obvious. And I think there are books which describe it to different extent. This is my own classification. I came up with it myself. But I tell you, for me, for example, I did not understand it before I became an investor. So between Parallels and Acronis, I founded Runa Capital, which is an investment firm. And we invested in about, I think altogether between different investments, maybe 300 companies. And to date, not from Runa, but from multiple vehicles. And to date, we had maybe 50 or 75 exits. And I've sort of really understood the difference between good and bad entrepreneurs. Ultimately, you have to understand, my definition of a good entrepreneur is somebody who can be serially successful.
It's a great definition. Sergey, thank you. Stay there. Konstantin, got another question from our audience. Why do you believe that SIT will make an impact in the way that education and research are done?
Well, because I believe in my own ideas, and what I'm doing right now is working at the boundary, at the interface between different branches of science: quantum, material science, computer science, artificial intelligence. And I see that by working at that interface, you really increase your abilities and broaden your horizons dramatically. And that's the philosophy which we bring to SAT as well. But probably the main reason why we believe in success of SAT is people. And this it has been mentioned already several times today, but the success of any project is guaranteed by people, and that's exactly what where we spend most of our time. How to bring the best people into SAT, and the best people, I mean the best professors, but also the best entrepreneurs and the best students as well. And if you do this, and you allow those people to collaborate, then the success will follow.
And Sergey, just on that point, because to me, this is, the greatest appeal. You showed the boards at SIT, and it's just incredible, the people that have been lined up on your various boards. Just explain to us, if you're watching today, if you're one of the students watching today, and you're doubting that they will have access to these people, can you just assure us that this isn't a facade? Those people on those boards, students have access to.
Well, Kosti is here, and this is I believe, third time or fourth time he's speaking just this year and allocating his time. And I don't know, they can talk to them in the process of being interviewed, or to some of them. I can assure you. But I think the reality is that this is a very interesting project, and it's not like we're forcing those people or not even paying a lot of money to those people for them to participate. It's just something which has to be done, and they're interested and they will participate.
Gentlemen, I wish we had more time, but we've got lots more to come in today's Alumni Insights. So I'm going to say a massive, massive thank you to Sergei Belousov, of course, the founder of SIT, CEO of Acronis, and Konstantin Novoselov, Nobel Prize winner, chairman of the SIT Strategic Advisory Board as well. Thank you both for joining us for that fascinating Q&A. There's so much to move on with, and this is a wonderful part of today's SIT Alumni Insights, where I introduce to you the SIT students in a wonderful short video.
All through my graduation, undergrad, and during my school, the one biggest problem that we had is that whatever we learn is never really used directly in the industry. We learn all the theory, all the kind of research that we do. That's not what exactly is really needed in the market.
SIT has a lot of differentiators from other universities. Its approach from business needs to science. They work on the specific areas of science that are needed to business.
Both are really catering to the market needs. They are training students to become professional leaders as they go ahead into the industry.
SIT aims to create not any kind of specialist, but specialists that will occupy chief positions at tech companies.
I really hope that the way that SIT is progressing in the education domain is recognized out there and is also followed by other universities, because tomorrow that is going to be the need of the hour, to understand the industry.
To widen your network, to get people, to get chief level people into your network, and also to get people from different cultures and students. We'll work on technology projects in future, help me in my career.
Thanks to SIT students for contributing to that video and giving us a sense of what it means to be part of the SIT educative experience. I want to shake things up a little bit now, because we're going to do our first case study today on research, and I'm very excited to hear from Professor Bertrand Meyer, Provost at SIT, Chair of Software and Security as well. And Professor Meyer is also going to be joined by Gaël Guédier, who's an information systems student at SIT. So we've got a bit of a double header for you now. Bertrand, if I can hand the floor over to you.
So thank you very much, Marek. It's a great opportunity to describe a little bit our master's program. My field of research is completely different from that of Professor Novoselov. I work in program verification, that is to say, making sure that the programs that, as Sergei Belousov said, run the world, own the world, that these programs actually work correctly, and which is a huge challenge. I mean, how do we know that they run correctly? One of the characteristics of SIT is that there's a really close connection between research and education. There was a question about how accessible. You asked Mark actually how accessible our top people are. Well, you can see how Professor Novoselov is. You should have seen these scenes when we had another Nobel Prize, Wolfgang Ketterer from MIT, mesmerizing a couple hundred local high school students from Schaffhausen with experiments, very concrete experiments on what happens at very low temperatures. This is our principle. We want to take the best experts and make them directly available to our students. And our first own educational program is this great master in computer science and software engineering that we're launching now. The first students are going to come in September. Here are 7 reasons to join this program, which has already been mentioned by previous speakers. It's the only master that really focuses both on software engineering, which is a fundamental field, which again runs the world, and computer science in general, because you cannot do software engineering without a very strong and both deep and broad computer science background. We have a unique program. There's really nothing like it in the world, in which we are combining topics from technology and from management and leadership. You know, the developers are there. Developers are a dime a dozen. And if your CV says developer, okay, it's not going to impress that many people. What companies really want, what they are dying for, is people who have the technical savvy, but also the management and leadership skills. And this is what we're offering. People, we've made this point already. You know, we have a slate of absolutely world-class people in software engineering, in management, in leadership, but also in neighboring fields, in physics, as you can see, in digital management and other fields, so in a completely pluridisciplinary context. We are applying novel models of teaching, which I'm going to talk about more in a second, you know, flip learning. We have fascinating research and industry partnerships with all kinds of partners, both in top universities and in companies. We offer the possibility of double degrees with top 10 universities in the world, such in particular as our original partners, Carnegie Mellon University in Pittsburgh in the US, and National University of Singapore, which is where our student Emmanuel Gedia will talk to us from in a minute. And we offer attractive scholarships. So if you could go to the next slide. We offer, there are software engineering programs out there, actually not so many, but there are computer science masters. What we offer, which is not to be found anywhere, is this unique blend of three aspects: technical skills, you know, really solid computer science and software engineering. There's certainly we're certainly not doing anything on the cheap here, and we're going into the depth of these technical topics. But then also management skills for the kind of positions that Sergei Belosov mentioned earlier. You know, chief information officer, chief product officer, chief innovation officer, which companies really need and have trouble filling, and leadership skills. Next slide. So to be a bit more precise, of course, I'm not going to go into the full details of the program, but examples of courses in all three areas are the following. I'm going to pick a few in each. On the technical side, you know, quality is, of course, the name of the game today. Data science, cyber protection. The world runs victim to attacks all the time, and we cannot accept this. Software engineering, my field, you know, software engineering is not just about programming. Software engineering is about building large systems that are going to continue being used and being developed for years by tens, hundreds, sometimes more people, and which are going to undergo many different changes, many different innovations going through many cycles. So this is a full-scale engineering issue, full-scale engineering enterprise, which needs techniques from many different areas. Architectural strategy, dynamic analysis. Professor Novosiolov mentioned how important deep learning is to physics and new materials in particular these days. So we're going to have in-depth courses on these topics. System protection, quantum informatics, which is the new kid on the block in the computing field today, and others. Management, you know, things like programmatic marketing, product design, transformational change management, product vision, and then leadership. Sergei emphasized a lot the importance of entrepreneurship. Modern society has been moved forward by people like Bill Gates and Steve Jobs and Larry Ellison and of course Sergei Belosov, and we want to train the next generation of entrepreneurs. Human and social psychology, agile leadership. This is one of the areas in which I have worked. You know, the principles of agility and a customer-centric mindset. So these are just examples of the courses that we offer. Next slide. So the program is largely the brainchild of my great friend and colleague Mauro Pezzei, who is formerly from the University of Milan and from the University of Lugano in Switzerland. He is a very influential member of the software engineering community, editor-in-chief of the main journal in the field, and with a huge international experience. And I've been, if you go to the next slide, I've been working hand in hand with him. My experience has been at ETH Zurich. I was interested by the question a few moments ago about, why go to SIT and not to ETH Zurich? So, I spent many happy years at ETH. I was even chair of the computer science department. And don't expect me to say anything negative about ETH Zurich, which is a fantastic place, but it's an old place. It's a traditional place. So it has the virtue and the benefits of its age and of its experience. And if you're looking for something a little bit more adventurous, something a little bit more multidisciplinary, where you can brush elbows with a physicist one day, a sociologist the other day, a political scientist the next day, and a boring software engineer like me the next day, well, come and try SIT. It's definitely going to be different. Next slide. And you don't get just professors. We talked about this fantastic network of people we have who are not necessarily on the register of the faculty at SIT, although they will be teaching courses, but they will not necessarily be full-time professors. They come from all walks of life. I mean, many of them are from academia, some of them are from industry, many of them are actually straddling the world of academia and the world of business. And so, where else can you talk to Arthur Eckert, who is one of the great innovators in quantum physics, to Barry McManus, who is an expert in human psychology and interrogation techniques, with Bruce Score, who is one of the leading people in agile development. And of course, well, you just heard from Kostya Novoselov, and you can see the kind of thing that you can benefit from at SIT. So this is one of the great opportunities at SIT. It's to get out of your shell. You are going to have all the courses, all the credits, all the exams, all the dotted I's and crossed T's that you would have in any good university, but you are going to have more of that. You are going to have opportunities all along. Next slide. Our mode of education is blended. So we didn't wait for the COVID catastrophe, which is, of course, is forcing everyone to rethink how they teach. But when you look at what many universities do when they say we're going online, well, they take last year's lecture and they videotaped it, and they put it online. Well, this is not very exciting. It's okay for a couple of months, as we have had in the spring. But imagine going like this for months and years. And it's not just the matter of COVID. It's that we have technology today in the same way that techniques of artificial intelligence and machine learning have revolutionized so many areas of business and technology. They can help us revolutionize the world of teaching. So of course, personal attention is always going to be fundamental. On-site education is going to be a key part of SIT education, but we are in the process of devising, in particular with our Alemira branch, new modes of teaching which combine the best of in-person on-site teaching and online remote education. And this also includes things like industrial projects and the kind of things that you do not typically find in standard traditional curricula, interaction with, of course, top-class academic instructors, not just at the level of the professor, but also at the level which is very important for students of teaching assistants, people who have the time to take care of you, to understand your special skills and your special needs, and of course, seminars, interviews with world leaders. And it's not just taking lessons online. The systems that we're building are going to be personalized. They will know about you. They will use AI techniques to make sure that the education that you receive is absolutely unique and tailored to your specific personality and mode of learning. Next slide. So some of the original aspects are following. So what you see on the right is an example of a robo-race car. Robo-race is an international effort, an international competition, in fact, to get to Formula One cars, which are completely driven by software. So the hardware is the same for everyone. What differentiates the various contestants, including SIT, is the intelligence, right? It's the software. So it's an example of the kind of projects that we are going to offer our students. Our master's program has a capstone project where students work in teams to build something really ambitious. Summers will be used for full immersion in industry internships. We have an industry thesis, a startup thesis, and of course, again, access to world industry leaders and constant interaction with industry, so that you can start working on your career, not when you graduate, which is typically too late, but all throughout your career and your studies at SIT. Next slide. I'm not going to go into the details of the program, but there's really two essential points to be mentioned here. One is that the master's program that we offer is a full-fledged European style, a European standard master's program. So it's not a reduced program. We will have other programs. You know, we have executive programs, we will have executive masters. There are room for these, they're very important, but this is not what this master's program is. It's a standard program. For those of you who are familiar with the details of a European system, there's a notion of ECTS, which is basically a European standard way of counting credits, making it possible in particular to exchange students between universities, and if you want to go abroad for a semester or two. And so in the top range of, you know, in the Rolls-Royce, so to speak, of a European master's program, it's either 120 or 140 ECTS credits. So we have three variants, and we can tailor the program to individual needs. The classic variant is 4 terms, four semesters, starting this fall with a summer internship. There's a fast variant, which is 3 semesters, but still the same number of credits. So it's not on the cheap. It's compressed. It's for students who want to work very hard, maybe students who are being sent by their companies. So they're going to do the same amount of work. They'll just do it a little bit faster. And then we have the really exciting possibility, which we have already inaugurated ahead of this program with our previous program, of a double degree with our partner universities, currently National University of Singapore, which is where Emmanuel hails from, and Carnegie Mellon, where essentially you spend the first year in Schaffhausen, or with a mix of on-site and remote education, but based in Schaffhausen. And then you spend your second year, your third and fourth semester at one of the partner university, and so you get a double degree, or more precisely, you get 2 degrees. You get a degree from us, and you get a degree from them. Next slide. So admission and scholarships, as was pointed out by Mark in particular many times, the place to go is sit.org/admissions. And basically, there are 2 ways to get admitted. The simple way is you have a bachelor in computer science or a related discipline from a recognized university. So this is the default. But, you know, again, coming back to the reference with traditional universities, we want to be flexible. We don't want to lower the standards. That's not the point. But in all traditional universities that I know, let's assume you want to do robotics, and for robotics you don't want to do computer science, and your bachelor's degree is in mechanical engineering, which is a very good preparation. Maybe you are missing a few things, but it's very good to be a mechanical engineer. Well, in the universities I know, you are not going to get admitted into a master's in computer science because you don't have the right degree. Well, I'm not saying we will admit you, but we will look at you. We will look at your CV, we will interview you, and we'll see if your strengths here compensate for your possible weakness there. The deadlines are very flexible. We use the shorter the better, the sooner the better. Let me state this clearly, because it definitely facilitates the processes, in particular for things like visas if you're not Swiss or EU. So the deadlines are September 1st and September 12th, respectively, for non-Swiss, non-EU, and for Swiss/EU. For a fast track and joint degrees, you know, the exact kind of program among the three that I presented in the previous slide, there's some flexibility. You don't need to choose right away. You can adapt as you go. And with respect to scholarships, we have many scholarship opportunities available. Basically, if you maintain an excellent grade point average, you know, if you're a good student, then we will give you a scholarship. Next slide, please. So, you know, one of the pleasures of being in academia, there are a few others, but one of the pleasures of being in academia is that you get to meet students, you get to work with great students. And one of these students is Emmanuel Gelgedia, whom I actually met in another university and who followed to SIT. He is one of our showcase students. He is currently at NUS National University of Singapore, and I'm really happy to give him the word and give us a little bit of the SIT experience as seen from one of our very first students. Emmanuel, the floor is yours.
Thank you, Professor Meyer, for your honorable and kind introduction. I'm Emmanuel Gelgedia. I am an SIT student studying at NUS in Singapore, information security as my major. So I graduated a bit more than 2 years ago from Innopolis University in Russia, where later on I started my career as an software developer and also a bit of DevOps. But now I am an intern in the research and development lab at Acronis in Singapore. Next slide, please. So what I need to mention here is that prior my master degree, I didn't have a professional experience in machine learning or cybersecurity. But thanks to SIT, I was assigned good supervisors from Acronis who kind of drove me through my learning process. And now I've made major improvement, and I have major improvement that helped me through my career and my dissertation, because the project I'm working on is at the same time the topic of my dissertation that I'm supposed to defend by late November, which is also supervised in academia by NUS. Next slide, please. So first we have to know what is a malicious URL and how we can use machine learning to fight against those malicious URLs. We might all be targeted every day by those URLs that try to either infect our computers or smartphones, or try to extract some information, critical information from companies, from individuals, bank card informations, and this is become more and more popular. So machine learning can help to automate the process to avoid all the burden, to avoid human mistakes, and to make it more automated, more faster and more efficient. So machine learning here will be used to automate the detection of malicious URL, and make the IT world a bit more safe. Next slide, please. So as you can see here, machine learning is a very considerable type of attack. Malicious URL is a very considerable type of attacks. These days, they can appear in any shape. You can find them on legitimate websites. You can find them from receiving emails, someone trying to imitate existing popular brands and try to trick you into giving out your information or installing a software on your computer. And it becomes expensive because you have to train your employees to detect those, even though it's not easy, but the companies these days have to invest into that, which is not always easy for small businesses. And as Stas Protesov said, it's mentioned these days, even into elections, people are trying to bring some sort of trickery into, intruding themselves into elections. Next slide, please. So we had to come up with a solution that will be, of course, better than the existing one. I need to mention that the existing ones are more focusing on the phishing type of malicious URL, while Acronis is more focused on the all type of malicious URLs. So, but the solution, we should make sure that we don't let the wrong URLs go through, and we should also make sure that we don't block the correct ones. That's why it's very important for us to have a low rate of false positive and also a low rate of false negative. Next slide, please. So far, we've managed to achieve better, to perform better in some sense than the current state of art, trying different approaches with the set of features we could extract from those URLs. We were able to try those features with different machine learning algorithms, and every time we were able to, we managed to outperform the state of the art techniques. But there's still a place to improvement, because the false negative rate is still high for such a solution. According to the business, it might be okay, but in this specific case, we still need to improve those results. Next slide, please. So later on, after those improvements, what I need to do is to finish my dissertation, which hopefully will also allow me to publish my work to a scientific journal, and have that solution to be integrated to Acronis Cyber Protect, because yes, is a product that they invest into this product actually is a good solution. So they plan to integrate that solution to their existing product. Thank you very much.
Emmanuel, Gael, thank you very much. Bertrand as well, thank you too. You're both back for our Q&A session at the end. So we'll see you shortly. And by the way, everybody, all of you out there, please press that Q&A function at the bottom of your screen. You've been asking so many questions to us at SIT. We're on standby, ready to answer your questions, and we're hoping to answer some of those questions at the end in the Q&A. So we're very much looking forward to that. Firstly, though, without further ado, I'd like to introduce our SIT students once again in this short video.
I chose SIT because of the kind of support that is provided in terms of the pioneers and the industry leaders, and the close contact with them in terms of where you are in your career and what aspects of career you want to focus more on.
SIT offers joint programs with Carnegie Mellon University and NUS. It's a unique opportunity to study at top-tier universities. Also, SIT offers a scholarship that fully covers education and living costs at NUS and Carnegie Mellon.
You know what is the most interesting aspect of SIT is that during our undergrad and during our school, we have been learning a lot of theory and a lot of textbook material. And when you actually go into the market, there is this huge gap created between our syllabus that you've been following and what's really needed. That they are trying to bridge that gap. They're trying to bring in the information that is really required to be a part of the industry right into your curriculum.
SIT is different because it's young university, what means that SIT students are in close touch with SIT administration and with SIT founders and SIT advisory board, and it means that we can define future of SIT, and also we can get a quick feedback on our project, on our results from inspiring people.
Thank you to all the SIT students for contributing to that video and for sharing their experiences of working with these world leaders and top physicists. It's such a wonderful opportunity, this new MSc course in computer science and software engineering. Please apply sit.org or sit.org/admissions and keep firing those questions on that Q&A function. You've been sending us so many questions. We're on standby, ready to help you, ready to answer your questions, or you can fire some questions on the website sit.org, admissions. I'm very excited. It's our case study number 2 on business, and we're joined by Dr. Stanislav Protasov, president and co-founder of Acronis, and of course, honored guest lecturer at SIT. And it's another double header. We're thrilled to be joined by Arpita Ghosh, who is a product management student at SIT. Stanislav, I'll hand the floor over to you.
So I will start with this slide, which you saw already today, showing multiple chief officers' roles in the software companies today. And I would want to talk a little bit, because basically the first question which you might ask, if I'm working in a startup or in a small company, why do I need those 15 guys? The truth is that when I started my software engineering journey, there were no such roles at all. Actually, 30 years ago, you would find probably director of engineering in software company, and in some companies maybe chief software officer. But the roles like chief program officer and chief security officer, chief architect, they appeared later. They appeared because there are obvious necessity for someone to take that job and make it done. And when you have a small company, essentially all those roles are also exist inside your company. The only problem is that one person plays several roles, and some of those roles he plays very well if he is trained for that, or he has some intrinsic characteristics which helps him to succeed in such a role. And some of the roles, the person simply fails. So when the company grows, you need actually somebody to do those roles very good. I watched this movie called Split when I was on the plane route into Schaffhausen. And it's an interesting movie. It's about a psychopath who actually has 23 personalities living in him. And the actor is very good, very convincing. But unfortunately, most of us are not psychopath, and as such, we have at most 1.5, maybe 2 personalities living in us. However, in order to succeed in your job, you often need to have multiple personalities. You need to be a manager, you need to be a leader. And around 10 years ago, I was discussing who is the good engineering leader in the modern software company with Bertrand Serlet, who used to be senior vice president of engineering for Apple. And he is the guy who is behind first versions of iOS, macOS 10. And before that, he actually was a creator of next operating system. And he told me that a good engineering leader should be a visionary. He should be very hands-on and understand very well software and computers. And he should be a very good manager. And I told him, look, but it's almost impossible to combine all those 3 in one person. And he answered, yes, it's impossible. So you need to figure out which parts you're missing, and you need to find a person who will actually do this job for you. And that was actually the answer of good and experienced leader. And leaders are different from managers, because manager, his major job is actually to keep the company running. One's leader job is to have the company to success over the years. And there is a book written by Lee Iacocca, who used to be CEO of Chrysler Corporation and who actually saved Chrysler from bankruptcy. And he wrote a book about that. And his less known book is called Where Have All the Leaders Gone? And actually, it's a very good book which can give you very simple and precise understanding of leadership. And according to Lee Iacocca, the leader actually have 9 C qualities. It's curiosity, creativity, communication, which means that the leader talks to people, he understands what is going on, and he is able to deliver the mission and motivate people. For that, he needs character. Definitely, leader need to have a courage, because often leader needs to do non-popular or drastic decisions. Leader needs to be convincing, and this also means that the leader himself should believe in what he is doing. Leader needs to have a charisma. Leader who is not competent is not a leader. And common sense. Common sense is actually a very good quality helping to navigate through multiple decisions and life situations. But the most important C is not here. It's actually crisis. The crisis is what get the leader born. So when the person goes through a crisis, he becomes a leader. The good thing is actually that most managers, they do have some leadership qualities, and most leaders, they do have ability to manage the teams. But the worst thing which can happen to the company is when manager who is not a leader starts thinking that he is a leader. And you probably can remember such examples from the industry yourself. So just a little bit about different leadership roles in a typical software company. Chief Development Officer. Ben Fati is a great example. He used to be the guy who actually was responsible for Windows operating system kernel. And he was known in Microsoft as a Mr. No, because Chief Development Officer, if he wants to deliver good product with good quality, he should be able to cut as much things as needed. Chief Technical Officer, Mark Bregman. Chief Technical Officer, as a matter of fact, is a visionary. But he is a visionary, he shouldn't be making mistakes, which means that he defines what the company will be doing, not today, but tomorrow. And if he is making a mistake, then the company may cease to exist. Chief Science Officer is actually close to Chief Technical Officer, but different, because for Chief Science Officer, making a mistake is actually produces the valid result. So we know where we should not go. And Peter Lee is a great example of Chief Science Officer, and he created multiple products and technologies such as, for example, Show Eyes, which is used in WeChat or Facebook. It's actually a bot technology. Chief Information Officer, the most paranoid and probably the most conservative guy. But again, Martin Hoffman, for example, helped Volkswagen, where he was in charge of IT for 20 years, to transfer the IT infrastructure to the level that it capable to support the biggest automotive manufacturer of the world. Chief Information Security Officer. I like Andy Ellis from Akamai as an example because he was the guy who transformed Akamai infrastructure from plain text passwords, as it used to be many years ago, to zero trust technology. And that's actually quite difficult task, especially taking into the account that Akamai is definitely a very attractive target for a malicious group all over the world. And Chief Architect. I put here Bill Gates because despite the fact that we all know that Bill Gates is founder and former Chief Executive Officer of Microsoft, I personally think that Bill Gates did more for Microsoft as a Chief Architect than as a CEO. And he defined chief architect roles as programmer's programmer. So chief architect is the guy who moves all the effort of many thousands of software engineers in one direction. If you have so many roles and if you have so many guys, how you actually make it working together? And here I will give a very simple example, which is known to everyone who was running software engineering organization. So if you have R&D team, should you actually assign those roles like developers and quality assurance engineers into product units, or you have to keep them separately? There are multiple pros and cons. If you actually have divisional structure, then you risk to face a situation when actually some divisions are doing great and some divisions are low performing, and products they're producing is actually hitting the reputation of the company. And if you have it per function, then you probably have predictable performance everywhere. But unfortunately, some of the products receive less attention, and moving people between projects creates some tension in the teams. The way we currently solve it across the industry is quite simple. It's a matrix structure. So essentially, and all the companies existing today switch between different approaches, and most of them ended up to have this matrix structure. When you have product team working together, however, you have control function which actually cares about best practices to be propagated across organization, and so on and so forth. For quality assurance, it's usually called quality control function, which defines the KPIs of the organization and the way it works with the engineering. One more thought on possible career tracks in the modern software companies. It's actually not specific to Acronis. It's the same in most companies today. Microsoft, Intel, Oracle, you name it. So there are two tracks, individual track and management tracks. I try to put the roles which are more probably to a particular track. However, you should keep in mind that actually it's it could be very confusing, because chief architect usually also have a team of architects, and that team can be hundreds of people. And you also should keep in mind that switching between tracks from individual contributor to management position is possible in all the companies. For example, the most interesting example I know is Dave Cutler, who used to be manager for Microsoft Windows NT. He created first version of Microsoft Windows NT, and right now he is technical fellow at Microsoft doing quite interesting research. Would not spend more time on that. Bertrand was great explaining why it's a good idea to join SIT. I would probably mention a bit that indeed technical skills, management skills, and leadership skills, it's unique feature of SIT, and all those three things are actually required in order to become chief officer in a software company. I would not stop on admission and scholarship as well. I would probably add one thing, and in order to become a leader, you need actually not only to learn those good things about computer science or physics, management, leadership, you also need to have a practice. And SIT gives you actually to get an access and to get a practice across your study. And our students actually works on real life projects, and I hope that Arpita will help me to illustrate it with her experience at SIT and Acronis. Thank you, guys.
Thank you. Hello, everyone. I am Arpita Ghosh, and I'm a student at SIT. I'm currently studying product management with our partner university, Carnegie Mellon, in the US. Next slide, please. Let me share with you my journey by far. I completed my bachelor's degree in computer science in India, post which I started working as a software engineer with a management consulting firm. As a software engineer, I worked with multiple teams, user design experts, professional services, but most of all with product managers. Our product managers were literally the CEO of their products, responsible from product conception to delivery. This is what got me interested into this stream and brought me here. So what I'm looking for is a shift in the career from software engineer to that of a product manager. So as you would expect, I need an intersection of concepts along with the guidance towards how to implement that in the real world. This is where the program specializes. I'm studying concepts of business, design, and technology at CMU while implementing them firsthand at Acronis through my summer internship, then a capstone project, and then a full-time role as a product manager in the company. Next slide, please. Today, I want to take you into slight depths of what I am doing as my summer internship project. Acronis specializes in cybersecurity products, and one of our leading platforms is Acronis Cyber Protect. The platform provides security tools such as data backup and recovery, malware protection, software patches, and so on. The latest addition to this suite is to be a data loss prevention solution. A data loss prevention solution aims at detecting and preventing data breaches, exfiltration, or destruction of sensitive data. Next slide, please. Last year, the DLP market was valued at $1.21 billion US, and this is expected to grow to $3.75 billion by 2025. Next slide. Now, why is this so important? Well, there is a plethora of reasons for that. To start with, government regularizes data security. You might have heard of GDPR, HIPAA, and such other compliances. Our company's data protection efforts also help build customers' trust on them. which is very important as by the day, more and more information is getting public. To add on to that, companies are also worried about unintentional data that is being leaked by their own employees. Next slide. So I started my project with a regressive study of what constitutes of an effective DLP solutions. To put it in short, data must be protected in 3 forms of existence. Data at rest is data that is present on an organization's various storage locations. Data in transit is the data that is moving across the organization's network. And data in use is the data that is being currently worked on. Next slide, please. The techniques to protect this data can be classified into 2 types. Preventive solutions, as the name suggests, is to try to stop data breaches from taking place at all. And detective solutions are the ones which try to detect breaches after they have taken place and take corrective actions on them. Next slide. So the next step in my research was to study what solutions are really working in the market and what are the ones that will suit Acronis's existing customer base the best. Acronis caters to the needs of managed service providers and managed security service providers. Hence, the most effective way to shortlist DLP solutions was to study what these guys need to provide services to their customers. The study concluded that about 60% of the MSSPs provide access right management through access control lists. 40% of them provide data discovery and classification features, while 30% provide device access control. Next slide, please. So let me tell you what these top features are. Data discovery techniques locate sensitive data or hotspots on your organization's network, and you get to know where your data really resides. Data classification tags this data for their level of sensitivity to make its value visible. Device control typically prevents unauthorized access or use of removable devices or BYOD devices such as laptops, pen drives, and so on. These features are also on Acronis's radar for their first MVP. Further important features are auditing, which tracks all actions that are being taken on a data for compliance and investigation purposes. Data access control would restrict user access to data, and encryption mechanisms would make sure the data is secure even if it manages to leave the office premises. Next slide, please. There are multiple DLP solutions that are already existing in the market. However, most of them are really complex and costly to implement, while only a subset of all features that the customers are paying for is actually useful to them. Acronis's DLP solution will aim at bridging these gaps by providing simplified self-help platforms and easy setup and deployment mechanisms. To help make solutions affordable, we will create convenient tool packages and billing options. The next steps in my roadmap is to finalize the feature requirements for the solution, work with our business analysts to build a pricing model, and work with the user design team to integrate the new solution into our existing platform. And with that, I come to an end of my walkthrough of the internship. Thank you for listening.
Arpita, that was brilliant. Thank you for your insights. Thank you to Stas for your insights. You're both joining us now for this Q&A. Please keep firing questions in that Q&A function at the bottom of your screen. We've got 6 wonderful speakers for this Q&A. Don't forget, if you want to apply, sit.org or sit.org/admissions. If you ever have a question, please don't hesitate to send your questions either below or to the website, where our team is always standing by. Let's get to the Q&A function. Okay, everybody. 1 question each, and please, because we've overrun, but it's been absolutely brilliant. I could go on forever. Please keep your answers fairly short. Vasily, if I could start with you, because we haven't actually heard from you yet. Was it difficult to pass all the exams and get enrolled with SIT?
I wouldn't say it was complex, and I also can't say that it was simple. I mean, actually, to successfully pass all these exams, you need to show all your knowledge that you have. And of course, you cannot prepare just in one night or even 1 month. You need to refresh your knowledge from your 4 or 5 years. And of course, you need to be confident in yourself and perceive all questions that you face as like facilitation questions that SIT asks you in order to understand who are you. So these are just facilitation, like to help you to present yourself to the commission. So don't be afraid and be confident.
Thanks, Vasily, for sharing that experience. Fantastic. Daria, if I could bring you in, why have you decided to proceed with your computer science education after your bachelor's in physics?
Hi, Mark. Hi, all. Thank you for your question. So I have a few passions in my life. Two of them are science and technology. And that's why I studied at Moscow Institute of Physics and Technology. And third one is that I really love to work with people. And during my bachelor, I tried myself in organization of students' festivals and came to the thought that I need to improve my leadership and management skills. And at the same time, I didn't want to leave technology area. That's why I was looking for a program that mixes technology and management. That's why I joined SIT, and actually I'm a bit jealous to new students who start studying at SIT from this semester, because as Bertrand said, there will be a lot of management and leadership courses such as behavioral science, human and social psychology, and I hope that SIT will allow us as alumni to be a part of these courses as well.
We'll be delighted. We'll be delighted.
Thank you.
Thanks, Daria. Arpita, if I could bring you back, I know you're very goal-oriented in your personal development, so I'd like to sort of get your crystal ball out. Where do you see yourself in 5 years' time?
Well, I think that for a product manager, the most happy thing is to see that their idea or their conception gets into the market, and it starts generating some amount of revenue, and it solves some problems for the real world. So maybe down the line, while working for Acronis or for such a company where there is so much innovation going on, I would really like to see myself bringing my ideas to the plate, running entire product lines, and being able to solve problems which haven't been solved in a while now.
Arpita, brilliant. Thank you. If I can bring in Emmanuel Gael. Emmanuel Gael, thank you. I've got a question about research. We all know that it's a creative work aiming to increase our knowledge. But one of the questions is, don't you feel that research done in a company is less creative and more driven by the need to solve a very concrete problem?
The short answer to this is no, because in the company, like of course the research are driven by product, but at the same time in the academia, they also try to solve like everyday's problems. So both are trying to solve problems, but some might be more focused on their product. But I don't think that something stops you from like bringing up your own ideas, your own way of solving those problems to your company, either to the company or to the academia. And what I've seen so far, some of our professors were getting projects from the company to work on them in the research labs in the university. So both are okay, and nothing will stop you from like being creative.
Thanks, Emmanuel Gael. Stas, if I could bring you back, do you think that a 2-year education is enough to take over C-level positions?
No. And basically, I would say that for most people, even the whole life is not enough. But you see, I would try to make an example. If you want to become a boxing champion, you have several ways to train yourself. You can read a book on boxing, you can watch Rocky and try to repeat Sylvester Stallone training track, or you can go and train with Mike Tyson. And actually, in the last case, you have the best chances to become boxing champion, because first of all, you're learning right stuff, and second, you're exposed to the world leader, to the real situation. And that's what SIT is doing, exposing you to the best scientists, to the best industry leaders, and to real life projects. So your chances just become way better.
Stas, thank you. Bertrand, last but not least, you're a student, you're watching this wonderful webinar. You want to hear from somebody like yourself who, as you said, was at ETH Zurich, and you're not going to put down that institution because you spent many wonderful years there, but just exude your passion and why you feel that students really should apply for this wonderful new innovative course, this master's course.
Well, I think Stas just said it very well. So I must confess that I haven't thought of myself previously as Mike Tyson, but I would say, you know, come wrestle with Mike Tyson.
A perfect way to end. I want to thank you all. It was absolutely brilliant. Thank you to all our wonderful speakers and all our SIT students as well, who all gave this enlightening vision of what this innovative education model is like at SIT, and of course this fantastic new Masters in Science in Computer Science and Software Engineering. So many nuggets. And by the way, if you missed anything, if you want to run through anything, everything today is available on the website, sit.org. If you have any questions, we run out of time, but please go to the website, sit.org or sit.org/admissions. We're always there to answer your questions, and we're really, really eager to hear from you. I want to thank once again all our students. Thank you for sharing your experiences, and thank you to all our world-class speakers as well. It was absolutely fantastic. Thank you too to all our attendees. Just want to tell you about, before I say goodbye, a couple of events we've got coming up for you here at SIT. 2 events I want to tell you about. September the 14th, that's the big day. Stick it in your diary. That's the launch of this master's, this SIT Computer Science and Software Engineering Master's program. You know where to apply, sit.org. And we're going to also tell you all about this event on September the 14th, 2020, the launch of the SIT Computer Science and Software Engineering Master's program. We'll tell you all about this course, sit.org/events. And a little bit later in the year, but something to look forward to, November 12th, 13th, SIT Insights in Technology Annual Conference for science, for business, for students. We've got world-class leaders, speakers lined up. This is your access to the latest technical developments and educational changes. You know where to find all our events, sit.org/events. I want to thank you all again for attending. It was an absolutely fantastic webinar, and a big thanks to all our speakers and our students as well. I'll see you all soon.
I love SIT because of the kind of opportunities we are getting with our projects. We are getting to build things right from scratch and bring it to the market. I love the fact that we are getting to learn in amazing partner universities like Carnegie Mellon and National University of Singapore. And of course, the most important thing is the fact that SIT is in Switzerland, which is one of the best, most beautiful countries in the world.
I love SIT because of the support that is being given to me, especially at these crucial times, and the kind of opportunities that are provided to me in terms of the industry experts that I'm interacting with every day, and the career path that I want to focus on and move forward with.
I love SIT because of close touch and close access to known scientists such as Konstantin Novoselov or businessman Sergey Belousov. They spend their invaluable time on us. I love SIT because of family of students and SIT admin staff and SIT advisory board that we grow together.